We are beginning our study of control systems, and first we're going to study manual motor controls. And the first subject within the study of manual motor controls is contact blocks. We're going to have some objectives with this lesson. First, we need to define a contact block. Next, we'll describe the possible states that an individual contact block can represent. And we should be able to distinguish between shelf states of a contact block. So what is a contact block? I have a picture of one here, but a contact block is a device that is used to control the flow of electricity. So in a manual motor control circuit, we're basically controlling the flow of electricity to be able to control some final control element like a motor or a valve. Let's look at some features of a contact block. Contact blocks can be represented by two states. One is an open state and the other is a closed state. The term state is a condition in which a device can be placed. Okay, so let's look at a simple light bulb. A light bulb can either be in the off state or it can be in the on state. Of course, if you have a dimmer switch, it could be in a varying between off and on. But if for a simple light bulb, we're just going to have two states, off and on. Let's look at some characteristics of a contact block. A normally open contact block means that normally it does not allow electricity to flow. We're going to define what normally means here in just a moment. And a normally closed contact block normally allows electricity to flow through it. The normal position is also can be referred to as its shelf state. So let's look at the definition of shelf state. It is the condition that a device can represent it when it is on the shelf or it's not being acted upon. Okay, so if I'm holding a contact block in my hand, it is in its shelf state. If I push its little actuation trigger, then it's going to be in a non-shelf state or its active state. Here are two opposing contact blocks. We only have two states that can either be normally open or normally closed. So to the left, I have a normally open contact block. Its shelf state is open, and it does not allow electricity to flow through it. Okay. Now below the description on the left, I have a little symbol that you'll see on the side of the contact block. It is a symbol that is supposed to denote the type of shelf state that that component represents. So in this case, you can look at that symbol and you can look at it as a bisection of a wall that has a door in it, and that door is open. So if you're looking top down from a wall and the door was open, it would appear like that, maybe in a blueprint or something like that. That denotes that that component is a normally open contact block. Now we have another indication, and it's the color that it represents. In this particular case, this one is colored green. Green is universally used for a normally open component. So if you saw this from a distance, you would know that this is a normally open contact block. If it is not color coded, some are just a generic black or clear plastic, you will have to look closer at the symbol on the side and that symbol that I have shown there. Off to the right hand side, I show the opposite shelf state that a contact block can have. A normally closed contact block is a contact block when it's on the shelf, it is closed, which means it's going to allow electricity to flow through it. Okay? The symbol that I'm showing there is much like that open door. It's the door swinging in the opposite direction, and then to the right hand side there's a little L shape, and that L shape means that that connection is made, and that means that electricity is going to flow through it. And again, from a distance we could even tell that this is a normally closed contact block because we have a red component. Let's look closer at a normally open contact block. This one happens to be a particular brand. It does use color coding, so from a distance we can tell the shelf state of the block. I have a outline of what you can actually see on the side of the component itself to the right here. In the top left, the ECX 1040, that happens to be the model number of the unit. Below that, it shows 15 amps at 24 volts. That's AC or DC, 24 volts. It has a tolerance that it can take up to 15 amps flowing through it. But if you're at a 400 volt potential, you're limited to 2.5 amps. So that's a very specific rating that is given to that particular contact block. It's definitely going to fit our needs. And then that symbol that I showed on the previous slide shows up there, and there's two numbers. If you notice, there's a .4 and a .3. That's actually terminal numbers that are assigned, and those specific numbers are specific to a normally open contact block. When we look at the normally closed contact block, we're going to see that the numbers are going to change. The normally closed contact block, which is in red for this particular manufacturer, looks very, very similar. There's two things that changed. One is the model number. The ECX 1030 is the model number for their normally closed contact block, and the number and symbol have changed. If you notice, it's the symbol from 2 slides prior, and the number system is 2 and 1, and those are terminal numbers. When we get into actually drawing out a motor schematic, those number symbols are going to be very important to us, and it's going to help us to note one from another contact block. Let's look at some varieties. So far I've just shown you one manufacturer, and that's the Automation Direct offering. That happens to be the normally open Automation Direct contact block, which is the ECX 1040. This is a German company, Schmersel. If you notice, this contact block is not color coded, it's black, so we have to look at the symbol, which you can see kind of in the upper right hand corner of that component, and it will tell us that it is a normally open contact block. And then this is an offering from Eaton. This is the HT8B, and if you notice, they look very, very different, but the function is the same. These are all contact blocks. The one from Eaton is actually normally closed if you look closely at the symbol, but the function of all three of those is identical. Okay, let's review. Provide a definition of a contact block. A contact block is a device that either allows current to flow or impedes current from flowing. Describe the possible states of an individual contact block. An individual contact block can be either open or closed. And distinguish the two shelf states of a contact block. That would be either normally open or normally closed.